Hi, this is Kimball Bullington. We're going to take a look in a multi-part video on how to attack this last problem. It's supposed to be a critical thinking problem, which means you're supposed to think. And you're supposed to think when there's not necessarily all the information given to you or you're told how to do it. But I am going to give you some help here. I know a number of people have struggled with this problem. Let's see if we can't give you a little bit of help. We're going to start with sort of reviewing the problem. Then we're going to move into going back to briefly review a problem that sort of holds the key to solving this one. And then finally, I'm going to step you through the beginning of setting up the problem to solve it. So this takes a little bit of thought. So this is based on a real problem. And essentially, we've got incoming parts from China headed towards Smyrna and to an automobile manufacturer, and there's a threat of a railroad strike in Canada, Canadian Railroad, so Canadian National. So this is based on a real situation that happened last year, right at the beginning of the pandemic, or maybe even before the pandemic was thought out. So I talk about the problem here, and there's 20 containers on a ship. A container is a 40-foot steel box. It says with a max gross weight of about 40,000 pounds, and that's a little bit useful. It's not going to come into anything that you're going to need, but to really understand the problem fully, you'd need to know that. And it's coming on a container ship that can carry 5,000 of these, but we've only got 20 on that ship. That's the important number to remember. So we have several options. One is to continue to Prince Rupert, British Columbia, and hoping that the strike will be settled. Cost of a shutdown, if it does catch us, is $12 million per day. That's US dollars. The second option is to divert to Vancouver for an additional cost. This is related to fuel costs and docking fees and so on, of $100,000, and that's $100,000 just to Nissan. And if there's a strike, truck the parts to Seattle onto Nashville via Burlington Northern, Santa Fe. And there's an additional cost of $300 per 40-foot container. Again, that's $300 times 20 containers. And then the final option, divert to Long Beach, California for an additional $750,000 on to Nashville via Union Pacific. What does this look like? Let's see if I can get this to where you can see this. I'm not sure. Okay, at the very end, I've inserted a little map here to give you an idea what's happening. So the first option is come up here to Prince Rupert, and as you do that, you're coming in on Canadian National Railroad, and that's this light green, and that's what's threatening to strike. Second option was to come in here to Vancouver, and then like truck south to Burlington Northern, Santa Fe. I'm not sure that that's really required, but that's the way we set it up in the problem, is that there's some extra costs and still a threat, which I think there could be, of getting caught in port and not being able to get out, and hence a threat of a shutdown. And making the trip on Burlington Northern Santa Fe, which is this red network. You might be coming in somewhere around Chicago, perhaps, and then getting on CSX down to Nashville here, or you may be coming down to Memphis and then over. So that's that option. And then the third option was diverting all the way down here to Los Angeles and taking, I said Union Pacific, which would be this yellow network. We could go Kansas City and down to Memphis, or we could go a southern route through Dallas and up to Memphis and then over to Nashville. Or we can get there one way or the other. Another option would be, I didn't word it this way, would be to take Burlington Northern Santa Fe out. This is actually the old Santa Fe Railroad route, and take this southern route. You see this in red, and we can end up in Memphis or St. Louis, and then CSX, whichever one is most convenient to get CSX into Nashville. So that in sort of a big picture, high altitude look is what we want to do. The cost associated with each alternative is not our typical cost, where we've got fixed cost plus variable cost times quantity. But our cost in this case is our fixed costs are actually the costs associated with choosing a particular alternative, and then the per container cost. And then the variable cost is not based on units, but in this case it's going to be based on the probability of shutdown. So it's like, and you'll see this in a little bit, it's like what we've done before, but there's a wrinkle, hence the critical thinking, problem solving. Can you take a tool in one area and apply it to a different area? I think you can. And so that's basically the setup. What we're going to do next is go back in time to Module 4 and take a look at that problem just briefly and look at it slightly differently to set us up for solving this problem. So there'll be 2 more videos, I believe, coming up. Thanks.